Hello everyone. In this video, I am going to explain about max element with queries. Max element with queries means you have given an array with elements. You have to find the maximum element with means after performing some queries. This is the brute force approach. This approach helps us to understand the basic logic of the problem and how range update works. Although it is not efficient for large inputs, it is very useful for starting point before learning the optimal solution. In this, we are given an array and a set of queries. Each query adds element x to all the elements between indices of S1 to L1. Okay, after all the queries, we have to find the maximum element. Now, the most straightforward way to solve this problem is to directly apply uh, each query by looping through the given range and updating the every element. Uh, we have given an array input having elements and queries with starting value and ending means starting index, ending index, and the value that should be added. Here, for the current array, the first query elements means uh, the starting index from 1 to ending index 3, we will be added the value 2. Okay, after first query, the updated array is this. And next, after second query, the updated array is this. Now we have to find the large element from the means the max element from this array. Here we can see that the max element is 6. For this overall process, the pseudocode is this. Here the length of array will be stored in n. For the outer loop is for the queries and the inner loop is for range updates and the final loop is for maximum element. Here the S1 will store the starting index, L1 will store the ending index, and X is for the value that should be added. And next in a loop the X value will be added for the elements, and next we will find the max element from the updated array. This is the pseudocode. And next, the time complexity for this process, this brute force approach is n into q. And the space complexity is big O of 1.
Hi everyone, I'm Hargeshna. Today I'm going to talk about the problem of settlement with queries and zero description when you have in cases of size and for also given few queries and it's IJ and it's for each query increment each value of their from index I to j with a value of x at the end after the performing few queries operations then the largest amount of the area. For this constraints are given as it was an integer no longer will be required. And we can see the test cases as well. Examples. There are two test cases. One is a render list of size 5 containing 1, 2, 3, 4, 5 as elements. There are two queries 0, 3, 7, and 1, 2, 2. It means I equal to 0, j equal to 3, and x equal to 7. And I equal to 2, j equal to j, I equal to 1, and j equal to and x equal to 2. We have to add the x element to the specified from the 0 I to j elements. So let us dive into the problem. So for this already brute force approach is already defined. We are removing we are lifting the approach because it has it has time complexity of big O of n into n. Of course, it was second u, so it can be big O of n square. For this, we have you taking the second approach as root sum and plus the difference array. For the test case one, we are applying the difference array. And there is a rule for the difference array technique, and that rule is uh, the difference we have to take a different and free an array with the size of array size plus one to minimize the edge cases and taking the rule as def def of I plus equal to x and def of a plus 1 minus c equal to x, and it is a rule designed for the difference array technique. So coming back our test case, so coming back our test cases, so for the query one is 037. So here the first rule is to difference array will be initially 0, 0, 0, 0, 0. So there will be six array, currently the array size is 5. So there will be six zeros added from it. Whenever difference of 5 plus equal to x, so it becomes 0 plus 7. So the value will be 7. For the difference of j plus 1, j is 3 here, p plus 1 4. Difference of 4 minus x is difference of 4 minus equal to 7 is 0 minus 7, 7. After the first query, the difference error will be look like this. 7, 0, 0, 0, minus 7, gen 0. Coming back to the second query, and it also containing the rule as the difference of def of I plus equal to x. It means def of I is 0 and adding element is x. So 0 plus 2 is 2. For this, j element is 2. So j plus 1, def of 3 equal to 0 minus 2 minus 2. After the secondary operation, the difference will be 7, 2, 0, minus 2, minus 7, 0. After that, let's go dive into a problem. And taking the max as the minus infinity, it can be called as integer dot min value, long dot min value. By the constraints, you can take it. And taking a variable current add as initially taking as 0, and draw a table that defines the index, difference array, current add element, array list, and the final value to calculate the max value. And defining the indices from the 0 to n. And as it was, the difference array also should be defined. The current add is 0. So the structure is for every I, the loop will be from I to n. Here n is the array list size. Currently, current add is element for every I. Current add plus equal to current add plus the difference of I. It means 0 plus 7. So, current add element variable currently holds the value of 7. And after that, taking a final value and initializing it as the current add plus current add plus area of I that comes to the final value. So 7 plus 1 equal 8. After that, max will be calculated. So here we have to use the math.max of my max comma the calculated final value 8. So minus infinity comma 8 equal to 8. So 8 is the maximum one. After that I will be 1 and that current at equal to 7 plus 2. It equals to 9. And after that final value will be calculated as 9 plus 2 11. After that max will be calculated method max of 8 comma 11. So the max will be updated to 11. After that I becomes 2. Here the difference has 0. So 9 plus 0, it is 9. 9 plus, and the area of 2 is 3. So 9 plus 3 equal to 12. So initially the max has 11. Now it will be updated to 12. After that, the index will become 3. Before 3 is minus 2. So current plus therefore 5. So it becomes 9 minus 2, 7. And the 7 plus the least current element will be stored in the final value and it will calculate it to the max value. Currently, the max value is 12. So level is smaller than 12. So 12 remains the same. After that, the last one is 4. Here, yeah, the difference element will be minus 7. So uh, current add element plus the difference element 7 minus 7, it leads to 0. And the last index of the element is 5. So 0 plus 5 is 5. It is also smaller than the 12. So the 12 remains as the max value. Hence, that always the answer. For this, the time complexity is for queries we are running n times loop, so few, and for this operation we are doing we are the loop will run n times. So it is plus. So it can be called as big O of n. And coming to space, it can be big O of n because we are creating a difference array and assigning values and taking the size as array of size plus array size plus one. Yeah, thank you.